Talked about what it means to be one-to-one, that if something's a function, we know x doesn't repeat, one-to-one means y doesn't repeat. We talked about what an inverse is, that it's just the opposite of something, so it's when x and y switch roles. And we talked about what that does on the graph, how it's a reflection over the line y equals x. Now we're going to actually find the inverse from an equation. And so these are the steps that we have to go through. First thing, it has to be written with x and y in it, so if you have f of x, you change it to a y. And inverse switches x and y, so that's what we're going to do. Where we see an x, we put a y, where we see a y, we put an x. Then we'll solve for y. Final step is we'll change our y to f inverse of x, just to use that function notation and label that we found the inverse. So let's take a look at a problem. If I want to find the inverse, step one says instead of f of x, we put y. Then we have to switch the x and the y. So this becomes an x, that becomes a y. Third step is to solve for y. So if I want to get y by itself, I can subtract my 3 and divide by 2. Final step is to put it back in function notation, so instead of y, we put f inverse of x. All right. I also asked for the domain and range of both the function and the inverse. So you'll see me write this, D for domain, the subscript of f just means for the function. Now we know the x's in the original become the y's in the inverse, right? So the domain of the function is the same thing as the what in the inverse? The range. So domain of the function is the range of f inverse. The range of the function is the domain of f inverse. Okay. So I know these are the same. It is easier to find a domain than it is to find a range. Domain, we look back here. Remember with domains we talked about problems. If you have a fraction, we can't have 0 on the bottom. If we have an even radical, it has to be greater than or is equal to 0 underneath the radical. I don't have either one here, so what's my domain? So both the domain of the function and the range of the inverse are everything. Negative infinity to infinity. All right, for this one. Okay, it's hard for me to look at this and just know the range, but the range of the function is the same as the domain of the inverse. If I look right here at my inverse, I have a fraction. In a fraction, the bottom can't be 0. Does 2 ever equal 0? No. So what's that mean it is? There's no solution that makes it undefined. So that means x could be anything. So the range of the function, domain of the inverse, negative infinity to infinity. Any questions? Let's look at this one. So I want the inverse. First step is what? Usually we'll go ahead and just take a step. Instead of f of x, we'll go ahead and put a y just so we have both x and y in our equation. switch our x and y. So this y becomes an x. I had two x's over here, so they both become y's. Now we have to solve for y. So if I want to get rid of my fraction, I can multiply my denominator. That gives me xy minus x equals 2y plus 1. I'm trying to solve for y. I have y in two different spots. So if I'm going to solve for it, I need to first get those on the same side of the equation. So I'm going to put those on the same side. These don't have y, so I'm going to put those on another side. So I'll just subtract over this 2y and add over this x. Alright, I can't actually subtract xy and 2y. What could I do though? GCF. They both have a y. Take out that y. So now this is y times something, so to get y by itself, we would divide. So my inverse, instead of y, we get f inverse of x is 1 plus x over x minus 2. So that one was a little bit more involved for solving. Are there questions on anything we did there? Right, let's do domain and range. I need it for both of them, but we know the domain of the function and the range of the inverse are the same. The range of the function and the domain of the inverse are the same. All right, domain of the function. If I look back at my original function, we have a fraction. We know that in a fraction, what can't happen? So x minus 1 can't be 0, so x can't be 1. How do we write that? It's a little bit harder to look at this and know the range. You can get it if you remember like horizontal asymptotes. But we know the range of the function has to be the same as the domain of the inverse. And if I look at my inverse, the domain is easy to find. We have a fraction. We know that in a fraction, the bottom can't be 0, so x can't be 2. So that one's negative moving to 2, negative 2 to infinity. All right. Any questions there or about the domain and range? I'm going to change this one, I think. I want a more interesting one. Let's say f of x is 1 over x minus 4. Let's do that instead. Do you guys think you could try to find the inverse there? Possibly. Give it a shot. See how far you get. of x to y. You switch x and y. To get rid of the fraction, we multiply over the y minus 4. You have to distribute the x when you do that. So we get xy minus 4x equals 4. Remember what we're solving for. We need to get y by itself. So I can add over my 4x. Divide by x. So I will have 1 plus 4x all over x. Is that how I write my final answer? What do I put at the end? Instead of y?
Oh, yeah, -1.
Okay. Domain and range. You could list them all separately, but there's no need. We know the domain of the function and the range of the inverse are equal. The range of the function and the domain of the inverse are equal. Domain of the function. If I look at my original function, what can x not be? So my domain is everything except 4. Negative infinity to 4, union 4 to infinity. Right, for the inverse, it's harder to look at it and know the range of the function, but I can look right here for my inverse and get the domain. It's a fraction, and a fraction, the bottom can't be 0, so x can't be 0. So negative infinity to 0, union 0 to infinity. Yes.
For like a test or like our work,
Mm-hmm.
does the d of f and r of f, do we have to put the equals r of f over?
So I asked for the domain and range of both the function and the inverse. So you need to have them somewhere. Now, if you prefer to list like domain and range of the function, domain and range of the inverse, you can.
Oh, okay.
But I asked you for all 4 things. So make
Okay.
sure if you want to do this, just tell me which ones are the same. Other questions? Let's try another one. All right, what's my first step? Good. So we change the f of x to y, switch x and y. All right. Now what? Good. So if we distribute, we get xy minus 3x equals y plus 5. So I'm trying to solve for y. I have y in multiple places, so we need to get those on the same side. And everything without a y on the other side. So I'm going to subtract over this y and add our 3x. Now what do you do? Take a factor out of y. So then to get y by itself, we divide, so we have 5 plus 3x over x minus 1. Final step, instead of y, we put f inverse of x, that f to the negative 1. So there's my inverse. Domain and range for both the function and its inverse. So we have 4 things, but we know the domain of the function and the range of the inverse are the same. The range of the function and the domain of the inverse are the same. Domain of the function, if I go back to my original function, then I know x minus 3 can't be 0, so x can't be 3. So it's everything but 3. Negative infinity to 3, union 3 to infinity. Range of the function is harder to find, but we can do domain of the inverse pretty easily. When I look at that, what can x not be? Negative infinity to 1, union 1 to. All right. Questions on those? Do we need more examples like this? So you guys know how to find an inverse. Okay. Last couple slides. These are just good thinking questions for us. Suppose f of x is the number of cars that can be built for x dollars. What does f inverse of 1,000 represent? So, we need to think about the function and the inverse here. In my function, think about order pairs, x, y. X is the dollars. What did y represent in the original function? The number of cars. Okay. Yesterday we talked about how an inverse flips x and y. So in the inverse, what does x represent? And the y is the... Okay, so if I say f inverse of 1,000, the 1,000, the number I'm plugging in is the x value of the inverse, so it is number of cars. What is this whole thing representing? The whole expression will give me y, which is the dollars. So it's the cost in dollars to build 1,000 cars. So you could say, you know, if 1,000 cars are built, it costs this much in dollars. So we have to think about what x and y mean and know that in the inverse they flip them. So the number I'm putting in here is the number of cars being produced. Any questions about that one? Last question. The graph of a function is shown. Find the following. Here's the problem. The graph is for the function. What am I asking you questions about? The inverse, okay? We know that in the inverse, x and y are flipped. So, if 2 is the x value of the inverse, what did that represent on my graph? It was the y. So what this is saying is, on my graph, we have to find x when the y is 2. So if I go to my graph, when the y is 2, what's the x value of that point? So when I say f inverse of 3, since this is the graph of f, that means find x when the y is 3. So the point on my graph when y is 3 is what? Yes. F inverse of 9, what does that mean? Find x when the y is 9, because this is the graph of the original function. So that's right here. What's my x value? No. All right, not that these questions are hard, but they're sometimes harder to think about, because I gave you the graph of one thing, but I asked about something else. Okay, so you have to think about how those are related. Any questions? Okay, so yesterday I opened up a Math Excel assignment. You need to finish that.